Okay, so the topic of today's lecture is primarily about arrays. Now, since you have a background in C, this should be relatively straightforward for most of you. But Java arrays are a little different than C arrays. All right, so first of all, they're pretty similar in the two languages. Java arrays are somewhat easier and safer to use. The other thing is in Java, they're somewhat uncommon because the Java standard library provides more flexible container objects for you to use. So you probably learned about some kind of list in your data structures course. I'm assuming you've all taken that course. I don't know if you have. The standard library provides implementations of two different lists, several different sets, and several different maps that you can use. So most Java programmers tend not to use arrays when they need a linear data structure. They just use this list. However, arrays are useful for some things. So in Java and in C, an array is a container object. It holds a fixed number of values of a single type. Right? So that's also true in C. In Java, an array is a reference type. Right? So it's not a primitive type. Right? So in other words, an array in Java, if you ever make a variable that points to an array, then the variable holds a reference to an array. Right? So it doesn't hold the array object itself. As in C, the length of an array is established when the array is created. But unlike C, you can always get the length of an array, right? So if you dynamically allocate an array in C, you need to carry around you need to know what the length of that array is when you dynamically allocate it, right? So and you also, whenever you pass that array around to some function, you have to pass in the size of that array, right? You don't have to do that in Java. When you declare an array, Java programmers tend to declare the array variable differently than a C programmer. Right, so in C, the square brackets have to come after the variable name. Java programmers tend to put the square brackets after the type name. Right, so in Java, this looks like it's an array of double. Right, whereas in C, right, you would say collection is an array of double. Right, and you'd put the square brackets here. Right, so in Java, it tends to go after the variable name. I believe it's legal in Java to put them here. But most of the time, it's written like this, right? So when you declare an array variable, the tendency is to put the brackets after the type. So as in C, an array can initialize its size and its elements using the brace notation, right? So the first time you declare an array, you're allowed to initialize the array using a comma-separated list inside of square brackets. Inside of the braces. You do not need to specify the size here. In fact, it's an error if you do. The Java compiler will create the array of the appropriate size for you. Right. So in this case, it'll make an array of size 5 and set the elements to A, B, C, and of size 4 and set the elements to A, B, C, and D. Right. Now this is the initialization syntax. Right. So initialization means at the point where the variable is declared. Right, so you're allowed to do that, but you cannot do this. Right, so you can't declare the variable u and then try to use the braces to use initialization, to use the initialization syntax. Right, so if you create the array here u, you end up with you just end up with a variable u that points nowhere. Right, so it's an array. It's a variable that points to no array object. So in this case, you would have to write u equals something else here, and I'll show you the something else shortly. Normally, you use the what's called the new operator to specify the capacity or the length of the array. Right. So new is sort of like malloc in C. So if you want to dynamically allocate, so arrays in C in Java are also dynamically allocated. Right. There is no malloc operator or function in C in Java. Instead, you use this thing called new. Right. So the way you use it is here I've got a variable called collection. Right, it's an array of double. Right, I don't have the initializer here, So I have to, at some point, before I use the variable collection, I have to make an array, and I have to make a collection point to that array. Right? So the way you do that in Java is you write new, the element type, square brackets, and then the number of element, the size of that array. Right? So this would be like writing malloc 10 times size of double in C. Now, unlike C, right? So when you know that in C, whenever you malloc, whenever you dynamically allocate something, you have to free the memory associated with it. So Java gets rid of all of that. So the you never free this allocated array. Right? The garbage collector will take care of freeing the memory for you when the array is no longer needed. Now, also unlike C, if you make an array of primitive type, right? So I make an array of Boolean, or I make an array of int, or I make an array of double. When you write new blah, right? The compiler automatically fills in the array with some default values. Right? So if I make an array of 3 Booleans, right, and I print out the array, so I'll explain this in a second. So when I print out the array some bools, you'll end up printing the array false, false, false. Right? So arrays of Boolean are automatically, the elements are automatically set to false. For the numeric types, the elements are automatically set to 0. So some ints, when I write new int 4, it automatically gets filled in with 4 zeros. And some doubles, when I write new double 5, it automatically gets filled in with 5 values equal to 0.0. Now, just like in C, right, there's no way to print out an array. I can't just print out an array variable. So if I wrote out system.out.println and then some bools, you end up with getting some strange output. You don't get the array printed, right? So just like in C, you have to write your own little loop to print out the elements of the array. Now, that's a very common operation. So Java makes it easier to do. Right? There's a class called big A arrays. Big A arrays is what's called a utility class. So it contains a bunch of public static methods that operate on arrays. One of the methods is called toString. So you pass it any array, right? And this method here will automatically convert that array into a nice string representation. So you'll get a square bracket. Oh, you know what? Why don't I just do it this way? So when I run, if I do this, right. So when I do that, what ends up getting printed out is false, false, and false. Right, so you got this handy method that automatically returns the string representation of an array, right? And then you can print out that string. So these are the default values for arrays of primitive type, right? If you have an array of Boolean, the default element value is false, and everything else is 0, right? And that includes char. So char, even though you think it's letters and symbols, it's actually a numeric type, so its default value is also 0. Okay. Right, so that's kind of nice, right? So you never have to worry about manually initializing the values of an array. Now, if you want to fill in the value with some other value, right, there's also this method called arrays.fill. So here I've got an array of doubles, right, of 10 doubles. If I print it out, I get 0.010 times. Right? If I want to replace the entire array with some other constant value, I can use the method called fill. Right? So fill that array with the value 1. And when you print out that array, you'll get 10 ones. Right? So that's handy, right? So this class arrays turns out to be quite handy. Now, I mentioned earlier that you never have to worry about trying to figure out what the length of an array is because the array itself knows how big it is. Right? So one of the hardest things to remember in C is that, or at least for new C programmers, is that when you dynamically allocate an array, there's actually no way after you dynamically allocate it to figure out how big it is. Right? If you have a fixed size array in a local, if you have a local fixed size array in a function somewhere, right, then you can use size of to get the size of that array. But if you dynamically allocate one, or if you have a variable length array, you can never get the size of it. There's no way to get the size of it. In Java, right, you just write the array name and then dot length, and that gives you the length or the capacity of the array. Right. So in this case here, n is going to be equal to 10, right? The number of elements, the capacity or the length or the number of elements that the array can hold. Right. So that's also nice compared to C. You know all this. The values in the array are called elements, right? And you know that the elements can be accessed using a zero-based index, right? And you access them the exact same way in Java that you do in C. You use the square bracket notation. Right, so remember there are no pointers in C, so if you know how to access an array element via a pointer, right, so you take the address of the first element of the array and then add a number, right, you can't do that in Java. You always have to use the square brackets. Last element in this array of size 10, right, you know that that's the length of the array minus 1, right, so that's the last valid index for an array. The first valid index is a 0. In this case, the array length is 10, so you can use the indexes 0 through 9. Again, unlike C, Java will check the index that you use. Right. So in C, you can use the index 10, and in most cases, it will not crash your program. Right. Something weird will happen. Well, you'll get some value if when you access the 10th element, the element in index 10, but it's not an element that's actually part of the array in C. Right. In Java, if you try to use the index 10, you immediately get an error. So I'll explain that in a moment too. So this is just an example of using an index to either get or set the element of an array. Right. So collection square bracket 0, that lets me set the first element of the array to 100. Right. If I want to get the first element, right, I just use collection square bracket 0, and then I can assign that value to x. Right, so just like in C, if you try to use index 10 or a negative index up here, right, you immediately get what's called an array index out of bounds exception. So attempting to access an element using an invalid index immediately causes an error. Now, in Java, errors are typically indicated by an exception being thrown. Right? So this is very different than C, where if you're lucky, when you try to access an invalid element, when you try to use an invalid index to access an element of an array, if you're lucky, the program crashes. Right? If you're unlucky, it keeps on running, and you never know that there was an error has occurred. So you get these what are called exceptions in Java. So an exception is just a special kind of object that's created when something unusual happens, right? So the name exception comes from this phrase exceptional event, right? And an error is considered an exceptional event, right? So in attempting to index an invalid, attempting to use an invalid index with an array is considered an exceptional event. Now, the exception object carries information regarding the error, right? Which is also nice because in C, all you get is a segmentation fault, and then you have to try to figure out what the heck happened, right? In Java, you get this object. Inside the object, there's information saying what happened, and often you can get that. Often it's you can always get that information. Often it's automatically printed to the screen when the error occurs. So when an error occurs, your program immediately stops running at the point where the exception occurred, right? So if you're inside a method somewhere and you do something to cause an exception, the method immediately stops running at that point. And then the Java runtime system looks for a code called an exception handler. So I'll talk more about this in the course. For now, it's not important. Right? If it doesn't find an exception handler, then the program immediately stops running, and you get an error message printed to the screen if you have one. So that's kind of nice, right? You never have to. The language actually tries to protect the programmer from invalid array accesses. Okay, so a common operation when working with C arrays is you're going to loop over the elements of the array, right? In fact, you almost always do something when you're working with arrays in C in any language. Usually, you're doing something. Not usually. Often, you're doing something with every element in the array. Right. So here's a function in C. Right. In case you haven't noticed anything on a black background, that's C code. Right? It's a little more obvious when I'm teaching 124 because Python code looks a lot different than Java. But this looks a little bit like Java. Okay, so here I've got this max element function, right? It's going to take in an array of double, right? The size I pass in, so the size of the array I also pass in as the parameter size, right? And it returns the maximum value in the array, right? So it returns the double value. That's the largest value in the array. Right. Now, can you find the maximum value if the size is 0? The answer is no, right? It doesn't exist. And in C, you now have a problem, right? Because you now have to ask yourself the question, what on earth am I going to do if someone passes in an empty array, right? Do I return 0? Well, 0 might be the maximum element of the array, right? So, I mean, so that's not really a great solution, right? Do I try to return some other double value that indicates an array an error has happened? Right. Again, that's not the best solution in the world because whatever value you decide to return might actually be the largest value in the array. Right? And so now you have this issue of what on earth do you do if someone passes in an invalid array? So we'll leave that for now because this is not a C course. To find the largest value in the array, you just loop over the array. Right? And you just store the largest value that you've seen so far. Right? So I'm going to store the first value of the array as my largest value. And then I'm going to loop over the rest of the elements. Right? If I find an element in the array that's bigger than I, right, then I just set high equal to that element. Right? By the time I finish this loop, I've found the largest value, and I can simply return the value of high. So you can write the exact same code in C, in Java, right? It's exactly the same here as in C. The only exception is, right, I don't have to pass in the size of the array because the array knows how big it is, right? It's array.length. So there's one difference. The other difference is where that square bracket appears. Right? And the other difference is this particular method is public and static, right? Like all of our methods for the time being. In Java, right, if someone passes in a 0 length array, you're allowed to indicate to the caller that they've done something wrong, right? And so the way that you indicate to the caller that they've done something wrong is you throw an exception object, right? So the syntax for that is throw, new, and then some kind of exception. You have lots of choices for exception objects. Okay? For the time being, everything's going to be illegal argument exception, right? And then you use the round brackets, and you can provide a string that will get printed if the caller doesn't handle the exception. Right. So if you throw an exception and the caller doesn't handle it, the program will stop and this string will get printed. Right. So the whoever called the method or whoever's running the program will know that they tried to call max element with an array length of 0. Right. Notice the name of the method is max elem. Right. So again, we're using lower camel case, right, to name the method. Right. So first letter is a lowercase letter. Right, it's a multi-word name, so the second word starts with an uppercase letter. Right, so there are a couple of differences relative to C. In this for loop, you know this too, because if you do the same loop in C, the scope of I is the body of the loop. Right, so in other words, you can't use I here. If you need to use I here, then you declare the variable I right here before the loop. Right, but when you write it like this, the scope of the variable I is the body of the loop. So that's one type of loop in Java, right? So it's exactly the same as the C-style loop. Now, because it's so common to loop over an array or some other collection of values and do something with each element as you loop over it, Java has this other style of loop. Right? So in the 5th version of the language, something called the for-each loop appeared. Right? So here's a for-each loop. Right? So the for-each loop, it does away with the loop variable. Right? Oops, sorry. Right. So in the regular for loop, it's controlled by this loop variable. Here, there's still a loop variable, but the loop variable, you don't have to worry about updating it, right? Or testing when the loop is done. So the for each loop will do something for every element in the array. Okay? So the syntax is the element type that's in the array, right? Some loop variable name, colon, the name of the array that you want to loop over. Right? So the way you read this is for each element E in the array ARR. Right? And now E becomes your loop variable. Right? So once, now I can write if E is greater than high, then high must be equal to the value of E, and then I can return high. Right? So this is a the for each loop is created as a convenience. It's easier to use than the regular counting style loop from C. Right? But it's only useful if you're going to do something for every element of the array, right? And you don't need to access a different element of the array in the same loop iteration, right? So, oh, regular for loops. You know all this. So you know how to write a regular for loop by now. Oh, I'm going to go through all. It looks like I'm going to go through all of this anyway. I guess this is worth reviewing. I'm just going to quickly do this, right? So a regular for loop has 4 main parts, right? There's initialization, some sort of termination condition, some sort of update expression, and then a loop body. You may or may not know that 1, 2, and 3, these are all technically optional, so they don't have to be there. But it's a little unusual to see a for loop that doesn't have all these parts. Right, so initialization, that happens exactly once, right? The first time the loop runs, the loop variable gets initialized. Termination condition, the loop runs as long as that condition is true. So as long as I is less than the length of the array, the loop will run. At the end of every iteration, this is the update expression. So at the end of every iteration, that happens, right? So right here, right? So when the loop reaches that point right there, then I++ happens. Okay, so the for each loop is handy. If a for loop is missing one of the 3 conditions, how do you know which of the conditions the remaining expressions are? Have you not seen an example? Okay, so let me give you an example of a for loop where some of the parts are missing. Okay, so the easiest thing to well, not the easiest thing. One of the things you can remove is the initialization. So to remove the initialization, I can write this. So for semicolon, I is less than array.length. Right, so I can do that. Right, notice the initialization condition's missing. Right, because I've initialized. Oops, sorry. Because I've initialized the variable up here instead. The first assignment posted. No, the first assignment's not posted yet. We haven't really done anything yet, so you're not really ready for the first assignment. The first lab will come out later this afternoon. Right, so you can do that. Right, I can remove the update condition if I want to. Right, so you can do this sort of thing if you need to update the loop variable. If you want to update the loop variable inside the body yourself. Right. So I can write the equivalent loop as follows, right? So I can manually do the loop update here, the loop update expression here. So this is also possible. Sometimes you do this if you've got an if statement in the body of the for loop, and you want to change the loop variable by a different amount, right? So sometimes you want to update, sometimes you might want to do this, right? So I might want to increment the loop variable by 1, right? But it's possible where you write a loop and you want to skip over an element, so you update the loop variable by 2 or 3 or something else, right? So you can control the loop variable manually inside the body yourself if you want to, right? And then finally, you can remove the, if you want to, you can remove this condition as well, right? So now there's no termination condition, so this loop will run forever, right? And now inside the body, you can test for the termination condition manually yourself, right? So here I can write if I is greater than or equal to the array length, break, and that'll break out of the loop, right? So if you really wanted to, you could write the loop this way, right? Or you could do any combination of these things, right? So I can move this back and put it into the update expression, right? I can move the opposite of this condition and put it into the termination condition, and so on and so forth. So when you take out one of the 3 control parts, right, you end up having to do it yourself somewhere else. Sometimes you need that flexibility, right, but it's a little unusual. Okay, now for each loop. So a Java programmer will almost always use a for each loop if they're doing something for each element of the array, right? Now, sometimes you're going to write a loop and you need not just one element of the array, but you need 2 or 3 or 4 elements of the array in the loop body at the same time, right? So if I want to test if a list is sorted, right, I want to test if each element sorted in ascending order, right? So I want to see if it's smallest to largest. I want to test if the second element is bigger than or equal to the first, right? Then I want to test if the third element is bigger than or equal to the second. Then I want to test if the fourth element is bigger than or equal to the third, and so on, right? In this kind of, in this loop, I need access to 2 array elements at the same time, right? So in this case, it's more awkward to use the for each loop, right? In fact, there's no good way to do it. Well, there is a way, but it looks really awkward, right? Because the for each loop only has access to 1 element of the array in each loop iteration, right? So here I need access to 2, right? I'm going to start at the second element of the array, right? And I'm going to test, is the previous element, right, greater than the current element? Okay, so if the previous element is greater than the current element, I know that the loop is not sorted, right? It's not sorted in increasing order. So I can set is sorted to be false. Okay. Notice that this method here, there is a bug in it, right? The bug is if the array that gets passed in is empty, this is going to throw an exception, right? So if the length of this, oh no, sorry, I'm sorry, it doesn't. There is no bug in this method, right? So if the array is size of 0, length of 0, the loop never runs, right? And so it just returns true. So apparently an empty array is sorted. Okay, so how does this work? I think you know how this works, I think. So here's the first iteration of the loop, right? I starts as 1, right? I minus 1 is 0, right? We'll compare these 2 elements. 12 is not greater than 13, so we continue, right? 13 is not greater than 14, so we continue. 14 is not greater than 15, and so on, right? All the way down to 26 and 27, right? So 26 is not greater than 27, so we continue, and we are done, so that we return true in this case. Okay, so that's all this loop is doing. Now, as in C, a break statement will immediately break out of a loop, right? So instead of looking at all of the elements in the array, right, as soon as I detect that the array is not sorted, right, I can immediately break. That will exit the loop, so it'll come down to this statement here, right? And now we'll return false. Right? So you have break and continue in Java, just like you do in C. So in this example, right, 12 is not greater than 13, so we go to the next iteration. Right? 13 is not greater than 99, so we go to the next iteration. Now 99 is greater than 15, right? So we set is sorted to false, and then we break. So we never bother looking at the rest of the elements in the array. Right? So that's a little bit more efficient than the previous version. Right? The previous version always looks at every pair of elements in the array. This version only looks at pairs until it finds until it discovers that the array is not sorted. Right. So again, this is another example of a loop where you need access to more than one element of the array in each iteration. Right. So again, you probably want to use a regular for loop instead of a for each loop. So this method reverses the elements in an array. Right. So we're going to take this array A, and we're going to reverse the order of the elements. Right. So how does this one work? So J, that's the index of the last element of the array. Right. And I initialize I to be the first element of the array. Right. So inside the loop body, I'm just going to swap the elements at index I and index J. Right. So to swap two values in Java, it's the exact same thing as swapping two values in C. You make a temporary variable. Right. You assign one of the two values that you're going to swap to the temporary variable. Right. So I assign AI to temp. Right. Which means I now can remember the value of AI. Right. So now I can overwrite AI. Right. So I can set AI to AJ. Right. And then I can set AJ back to temp, equal to temp. Right? That effectively switches values. Now, I'm switching AI and AJ in the loop. Right. So J is the last element of the array for the first iteration of the loop. Right. So the second iteration of the loop, I want to swap the second and the second last element. Right. So I have to decrement or decrease J by 1 here. Right. So I goes up by 1 every time in the loop. J comes down by 1 every time in the loop. Right. So a picture of what's happening here is as follows. Right. So at iteration 1, I'm going to swap the 12 and the 27. Right. So I'm going to switch values to get that. Right. So 27 is switched with the 12. Right. The next iteration of the loop, I goes up by 1, J comes down by 1. Right. So swap these two values. Right. Next iteration, the third and third last elements, we'll switch those. Right. Eventually, we get to this point here. Right. I'm going to swap these two. Right. Iteration 8 ends. Right. And away we go. So what is my stopping condition here? Just a second here. I is less than J. Right. So there's your stopping condition. Right. So you're going to continue until remember J is the element in the back half of the loop. I is the index of the element in the first half of the loop. Right. So I know I'm done when I and J pass each other. Right. Or they're equal to each other. Right. So in this case, the loop stops after swapping the elements at index 7 and 8. All right. Now in the previous example, there's two loop variables of the same type, which means you can incorporate both loop variables into the initialization and update expressions if you want to. Right. So for example, I can write int I equals 0, comma, j equals a length minus 1. Right. So I don't need to have j as a separate variable. Right. And then in the update expression, I can write I plus plus and j minus minus. Right. So I can do everything inside the loop definition here. Right. Whoops, sorry. You don't have to do it this way, right? You can do it the other way as well. Here's another example. So this one I'm going to sum two arrays together and return a new array containing the sum. Now in C, you can't return an array, right? All you can do in C is return a pointer. And in C, when you write this function, you have to dynamically allocate the array that you're going to return. Right? So you can't make a little local variable. and then return the local. You can't make a local array and then return the local array, right? You have to dynamically allocate the array. In Java, right, you just make the array like you would always make it, right? So I'm going to sum the elements in A and B, right? If I want to do this, their lengths have to be the same, right? So if they're different, I can indicate that there's an error, right? Make the array that represents the sum of the elements in A and B, right? So that's just a new array of int that has the same size as A, right? Write your loop, and inside the loop, Ci is equal to Ai plus Bi, right? So sum every element of the arrays A and B, right? I can't use a for each loop here because the for each loop only lets you access the elements from a single array, right? There's no way to write a for each loop that accesses elements from multiple arrays at the same time. So I have to use the C style loop here, right? And then I can just return C. I don't have to worry about deallocating the memory for C or anything like that. Okay, now this is intentional, right? So now I switched to Python for some reason, right? So in Python, there's the notion of what's called a slice, right? So a slice of a list in Python is part of a list, right? So imagine that that's an array in C or Java, right? So 10, 11, 12, 13, 14, 15. In Python, you can write something like this. So T:5 means the part of T starting at index 2, so 0, 1, 2, so 12, going up to but not including index 5. Not including index 5. So that means 2, 3, 4, not including 5. So the slice of this list also is the list 12, 13, 14. Right? And that turns out to be incredibly useful for a lot of programming problems. Right? So it'd be nice to be able to slice out part of an array. Right? So for example, give me the first half of the array, give me the last half of the array, or give me the middle 3 elements of the array or something like that. Right? There's no way to, there's no library function that'll do that for you in C. The best you can do is something like mem copy. In Java, there's also no slice operator. So you have to write your own method. Right? But it's not hard to do, right? Using the stuff we've learned today. So I want to slice this array. I want that to be my starting index, right? That's one past the stopping index, right? So it's going to give me the array starting from this index, going up to, but not including that index, right? In Java, you should always test or you should always validate your input arguments, right? So if I want to slice this array, this number has to come before this number, right? So start has to be less than stop, right? If it's not, I should throw an exception, right? There's other things I should test as well, right? So what other errors should we check for? Right? I should check if start is less than 0, right? I should check if start is greater than or equal to the length of the array, right? Because those are invalid values for an index. Right? So I should check those as well. I didn't do that on this slide because I don't have room, but you should really check for those. Right? Now, how do I slice the array? Well, I need to make an array big enough to hold the slice, right? So how big is that? Well, that's just stop minus start, right? That's the number of elements in the slice, right? Now I just copy in the elements starting at that index. So I equals start, right? Going up to, but not including that index. So I is less than stop, right? I want to copy those values into that array there, right? So I want to copy the elements from array at index I, right, into my array slice. Right now, I can't use I on its own to index into slice, right? Slice starts at 0, so I have to subtract start from I to get the right index into slice. Right. So in the first iteration of the loop, I is equal to start, so I minus start is 0. Right. Second iteration of the loop, I is start plus 1. So start plus 1 minus start is 1, and then so on and so on and so on. To call the Java version of slice, right? So inside the class lecture 4, I've got my method called slice. make an array, right? And then I call the slice method, right? So lecture 4 dot slice, pass in the array t, right? I want to get the slice starting at index 2, going up to, but not including index 5, right? So that'll be the 12, the 13, and the 14 as an array, which is handy. Finally, this is the last example I want to show you today. In Python, you can copy a list by slicing the entire list, right? So if I want to copy the list t to get a new list that has the same elements, right? You just write t:, and that gives you the entire list, right? So in Java, I could use slice again, right? So I could use slice, and I can go 0, 5, and that will work. But Java arrays have a method called clone, and so I can just clone the entire array to get a copy. Right. Okay, so that's all I want to. That's the end of today's lecture. Does anybody have any questions? Anybody quick? All right, so we're done for today. Later on today, lab 1 will appear. Later this week, assignment 1 will appear. And that's it for today. So I think I have a question from somebody that I have to look at. So stop recording here.